So we have talked about derivative of a function, and the derivative of a function is the slope of the tangent line. So let's say we have a function here, okay, and so this is y equals f of x, and what we mean by derivative, which is f prime, that means we're looking at the slope at every point. So imagine those tangent line touching. So if I'm using a different pen here, you'll see those tangent line at every point going this way. Okay? So our goal here is to figure out how to find the slope of those lines at every point of the graph. And according to our definition, this is the limit. This is the limit of f of x plus h minus f of x all over h as h approaches 0. And where we got this formula is from the slope of the secant line. And so imagine here's your point x f of x, and let's say this point here is h away. So this would be x plus h, the x coordinate, and that would be f of x plus h. So you could see the differences of the y over the differences of the x's, and that's how we got this formula. Okay? So let's try one example. Let's say f of x is 1 over x squared plus 1. So we want to find the derivative or the slope of the tangent line of this function at every point. So according to our definition here, it would be the limit of f of x plus h, so that would be 1 over x plus h squared plus 1 minus 1 over x squared plus 1 all over h as h approaches 0. And so the task now is to simplify this algebraically. And you can see that what we have is a complex fraction. It's a fraction of fractions. So how do we simplify it is to remove those fractions. So we're going to multiply the top and the bottom by the denominators, x plus h squared plus 1 times x squared plus 1. Okay? And that means top and bottom. So x plus h squared plus 1, and then x squared plus 1. So by distributive property, when you distribute the those fractions, you get rid of this, this cross cancel out, and you're left with the x squared plus 1. So the first term is just left with x squared plus 1. The second term here, the x squared plus 1 cancels out, and then you're left with this term, so it's going to be minus. And I'll just go ahead and switch the sign, x plus h squared minus 1. And then I have all of these in my denominators, in my denominator. All right? So now let's simplify this expression. You could see that this is x squared minus 2xh minus h squared. And because this is minus, this cross cancel with this minus, the 1 here cross cancel with that 1. So in the numerator I'm left with, let's see, what do I have? A negative 2xh minus h squared all over h, x plus 1, x plus h squared plus 1. So I'm just copying what I have in my denominator. Notice that there's an h here at the bottom, and there's h's on both terms in the numerator, so I could cross cancel those. And so I'm left with the limit of negative 2x minus h, x squared plus 1, and then I have x plus h squared plus 1. And now let's check. Can we do a direct substitution? Notice that it's not going to make our denominator 0, so yes, let's go ahead and make this 0. Let's make this 0. So what do I have? I have negative 2x all over x squared plus 1 here, and that becomes x squared plus 1 also. So basically what I have is a negative 2x over x squared plus 1 squared. So what is this? This is a derivative function. It's a function by itself that represents the slope of the tangent line at every point of the graph.